Good evening, everyone. This is the class of Electrical and Electronics Measurement. Today, we will discuss about the topic of MI type instruments or moving iron instruments. So, last day we have already covered the part of PMMC type instrument, that is permanent magnet moving coil type instrument. So the basic difference in constructions and in working between PMMC and MI type instrument, that is for PMMC, that is moving coil type instrument. That means in a stationary magnetic field a coil is in moving nature, and when we are considering about the moving iron instrument, that means the coil in this type of instrument is fixed nature and the iron piece that is moving inside the magnetic field that is created by coil. Now when we are considering about moving iron instrument, that means we already know that here the magnetic field is created by the stationary coil. So the stationary coil can be created using copper or aluminium types of material. Now this particular coil is fixed in nature, that means that is in stationary nature. When a particular amount of current is flowing through the coil, so this coil is behaving like an electromagnet, that means this is going to behave like a magnetic material. Now the basic principle of the moving iron instrument is that there we consider about a piece of iron or vein of iron or a high permeability steel material that is moving inside the magnetic field. Now that means the magnetic field, the magnet going to attract the piece of iron. So how much it will be attracted, that is dependent on the amount of magnetism grow. So the amount of magnetism grow, that is again dependent on the amount of current flowing through the coil. So that is totally related. That means when a coil, when we are considering about a coil, suppose this is a coil, there is a voltage, now a current is flowing through the coil. So that means this coil is going to be a magnetic material and that is going to be an electromagnet, because through the magnetic field a current is flowing, the electrical current is flowing, so that is behaving like an electromagnet. So the amount of current going through this coil, that is a very much important thing, because based on that the amount of electromagnetism grows here, that is dependent. And so the iron, the piece of iron that is attracted towards the solenoid, towards the magnet, and by that term we can classify the moving iron instruments in two parts. One is attraction type, another is repulsion type. Now by the term there is a basic difference. Attraction type means there is a attractive force, attractive nature, and in case of repulsion type, that is a repulsive force. So now we have to go to the basic construction diagram of attraction type and repulsion type. Firstly, that is the construction diagram of attraction type moving iron instrument. So this is the part of coil winding which we already describe as behaving like an electromagnet, because the amount of current that is flowing through this makes it as a electromagnet. Now this is the moving iron. This moving iron, that means the piece of iron that is moving through this part, through this magnetic field. Now you see that a pointer is fixed with this moving iron instrument. So this pointer is fixed means how much the deflection, how much the movement of moving iron occurs, the deflection of pointer totally dependent on the movement, because when this moving iron is moving here, that means obviously, as because the pointer is attached with it, the pointer is also deflecting. That means there is a deflection torque. We know when we are considering about deflection type of instrument, there is three type of torque actually acts. One is deflection torque, another is controlling torque, and number 3 is damping torque. Now this is the construction, this is the coil, this is the moving iron, the pointer is attached with that. The damping torque is provided by the air damping chamber, and this is the controlling torque. That controlling torque is provided by the spring. Now when we are considering about the working principle of that, then what happens? Suppose in a system there is a deflections, there is a amount of increment of a current. That means that increment obviously does a change in this system, because that current is going to flow through the magnetic coil that makes it as a electromagnet, and the electromagnetic coil, the solenoid, that is going to attract the moving iron. Now what is the nature of moving iron? That iron is, the piece of iron is going to move through this coil, and that means this actually going to increase the flux, because we know that the moving iron actually always try to go through the low reluctance path, because that is the nature of a magnetic material, because reluctance is the opposing force. So obviously the iron path, as it is a conducting material, it is obviously try to go through the low reluctance path. And the nature of inductance is that we know when there is a varying current flowing through a coil, obviously the electromagnetic force is going to increase. We know that V equal to L di dt. Now this is the construction of attraction type moving iron instrument. Here the attraction goes between the magnetic coil and to the moving iron. Now another point is that is called repulsion type. The next diagram, that is called repulsion type. That means repulsion type means there is a repulsive force works. So the basic constructional difference between the attraction type and repulsion type is that in case of attraction type, you see that there is only one piece of moving iron. But now when we are going to consider about the repulsion type, there is suppose two vein. One is fixed vein, another is movable vein. That means there are two iron pieces. Now samely, when the current is flowing through the electromagnetic coil, that is going to magnetize, and in turns it induces the magnetization to these two coils. One is fixed coil, another is moving coil. The moving iron, that is the fixed vein part, that is the movable vein part of iron. Now two iron piece, both are magnetized, so obviously they goes to repel each other. So that is the repulsive force between this movable vein and this fixed vane. That means this movable vane is going to distanced from the fixed vane because of that repulsive force. So this type of instrument is called repulsion type moving iron instrument. Now, in repulsion type of moving iron instrument, there is another two category. One is radial type, another is coaxial type. That means this diagram is a figure of radial type moving iron instrument, because the vane, that movable vane and fixed vane, that is the strips of iron in radial nature, that is actually in radius. So that is the radial type of moving iron instrument. When we are going to consider about coaxial type, the irons are actually like a coaxial cylinders. So this is the basic difference between the constructional difference between the radial type moving iron instrument and coaxial type instrument. That means the iron vein that is through the radius, and here that is like a coaxial cylinder. Now, when we are considering about these types of instruments, now we have to go through the basic equations, because we know that when we are considering about deflection torque, controlling torque and damping torque, there will be some mathematical equation like we already do in PMMC type instrument. Suppose there is a increment of current, that is we considering about di. So suppose we know that I is the initial current of the instrument, L is inductance of instrument, I the initial current that is flowing through the instruments, theta is the deflection. We know that in case of PMMC, that deflection, that is totally because of the flowing current. Suppose the value of current is increasing or decreasing than the normal current, then obviously based on that the deflection also going to change. So now here suppose there is a change in current, that is di. For that there is also a change in deflection, that is d theta. That means for di current change, that is d theta of deflection change. Now what is the mechanical work done? That is Td into d theta. That Td is going to be a deflection torque. Now when we are considering about EMF, we know that E equal to ddt of Li, because we know when there is a consideration of varying current, that means obviously the EMF will increase, that is E equal to ddt of Li. So that is I dl dt plus L di dt. Now we have to consider about the energy part. So we know that energy equal to the voltage into current and into the time, the rate of change of time. So when we are considering about the energy supplied, obviously electrical energy, so that energy supplied equal to E I dt, that is equal to I square dl plus IL into di, because this is the equation. See, when we are considering about ei dt, that means that is I dt is multiplied, that means that is I square, dt is cancelled, that is I square dl, and here that is IL into di, again dt is to be cancelled from the previous equations. Now we know that another energy formula that is we considering, that is half Li square. So suppose half Li square, this is my initial energy, and now there is a small increment of energy, that means the energy consumption is going to change because the change in current in the system. So that is going to be half I plus di square into L plus dl. So the change in stored energy, so what will be the change in stored energy? So that is the difference between the final energy form and the initial energy form. So I have to differentiate between these final energy form and the initial energy form. So that means if we are neglecting the higher order term, then what will happen? The form is ILDI plus half I square dl. Actually you have to do the subtraction between these and these. If we do the subtractions, we know that that half Li square term and the another 2-3 terms are going to be cancelled out, and now we are going to cancel out and neglecting the higher order terms for our convenience. So this is the actual term we can get. Now electrical energy supplied equal to, what is the form? Energy supplied, that is equal to increased in stored energy plus mechanical work done, increased in stored energy plus mechanical work done. That means from that point of view we can get that. So energy supplied, what is the form of energy supplied we get? That is previously I square dl plus IL di, that is we get from this equation, that is I square dl plus IL di. This is the amount of energy supplied, that is equal to the increased in stored energy. So the change in stored energy, that is IL di plus half I square dl plus the mechanical work done, that is Td into d theta. Firstly we get Td into d theta, that means that is plus Td into d theta. So from this equation, if we are doing that, see this term going to be cancelled out, and Td that will equal to half I square dl into d theta. That means from this point of view, that is the deflecting torque, that is dependent on the amount of current flowing through the coil, and for that is the deflections of theta. So this amount of current going through the coil, that actually going to electromagnetize the coil, that electromagnet going to attract the iron vein, and the pointer is attached to the iron vein. So the current is related to everything. Now we are going to considering about the controlling torque. We know that in any deflection type of instrument, the controlling torque will be equal to the deflection torque when that is in balance condition. So Tc should be equal to Td in balanced condition. So what will be Tc? So Tc equal to c theta, where theta is the amount of deflection and c is the spring constant that is dependent on the materials that were used for the spring. So c theta equal to half I square dl d theta. That means theta equal to half I square by c dl d theta. That means we know that this theta, this is the amount of deflection that is directly proportional to the square of the current. That means the current is the main thing that is flowing through the coil. So for this reason, when previously we are going to discuss about the construction and the working principle, then we priorly mentioned that current is going to the coil. This is going to be an electromagnet, and that electromagnet going to attract the iron. Now that is in two part, the attraction part and the repulsion part. So when we are considering about attraction part, the electromagnet going to attract the iron, that is for attraction type of instrument. When we are considering repulsion part, then we are considering actually about the two iron vanes, because when we do the constructions, we see that in repulsion part there is two iron vane. So one is going to be fixed, another is movable, and fixed vane and movable vane both are now magnetized because the electromagnet. So this is going to be do the repulsion to each other. So for that, one is repulsive type, repulsion type, another is attraction type. Now this is the basics of moving iron instrument. We are considering about the moving iron instrument construction, moving iron instrument working principle, and the moving iron instrument theory with the mathematical part. Now see, suppose we are considering the current flow. The very much advantageous part of the moving iron instrument is that the moving iron instrument can work both in AC and DC, because if the current is flowing in opposite direction or both directions, suppose the current is flowing in whichever the directions, the moving iron instrument can work. So that is not dependent on the direction of current. So from that point of view, we can say that moving iron instrument can be used for both AC as well as DC. Now we are going to discuss about the advantage parts. So when we are considering about the advantage parts of moving iron instrument, the first point again we can see that both AC and DC measurement. Second is what? That is the frictional error is less due to the high torque to weight ratio. That means we know that when we are considering about any types of deflection instrument, then the frictional error is very much important issue, because if the frictional part is much more, then the pointer is not going to deflect properly. The moving iron instrument is a good accurate instrument and its range can be extended. So these are the basics advantages, and the disadvantage parts are that is a non-uniform scale. The scaling is not uniform for moving iron instrument, and for that reason, when that is the pointer is going to the furthest end, then it is going to be cramped and not going to show the exact value. The difference between AC and DC calibration, it is another important point when we are considering about AC calibration and DC calibration. That is not same for the moving iron instrument, and for that reason we have to consider a frequency calibration. The moving iron instrument can do the work between 25 Hz to 125 Hz range. There is a temperature error that is a very much basic error because we are considering about the conducting material, and the conducting material has the characteristics that the resistance is going to change with the change in temperature. So we have to do a series resistance. We have to add a series resistance of material that is like a low temperature coefficient or zero temperature coefficients like manganese. We have to use to overcome that temperature error. The power consumption is also high for moving iron instrument, and the error is again the error that is going to happen in moving iron instrument, that is hysteresis error, temperature error, frequency error, eddy current error. So hysteresis error, already we defined that hysteresis error means for the same flux density for ascending and descending current, they don't show the exact value. So that is a hysteresis error. We know that for the hysteresis part, for the magnetic material, there is always a hysteresis part that affects the value, the reading. When we are considering about the another error that is called temperature error, we already considered it as a disadvantage. Frequency error, because we know that if we considering about the change in frequency in AC system, we know that the XL equal to 2 pi FL. That means if the frequency is changed, that means the total reactance part is going to be changed. So that means this going to hamper the accuracy. And the eddy current error, that is also a part of AC instruments. Here when you are going for the AC calibrations, this affects the eddy current also induced to the iron part of the instruments, and that also change the actual value of current. The reading of current going to be hampered. So these types of error actually we can see in case of moving iron instrument. So that's all we are considering. We are discussing all about the moving iron instrument. Thank you.